Hello and welcome to a new episode of TarGZ. Today we talk about fairness and relevance, recommender system, very interesting topic. And our guest is Theresia Veronika Rampisela, postdoctoral researcher at Copenhagen University. Welcome, Theresia.
Hi, thanks for having me.
Yeah, it's a pleasure. Would you like to introduce yourself?
Yeah, sure. So I'm currently a postdoctoral researcher at University of Copenhagen, so it's in Denmark. And I'm going to talk more about the research I completed during my PhD here, also at the same university. And it's on fairness evaluation of recommender systems. So in my PhD research, we look into how fairness has been evaluated in recommender systems. And as you may know, there are many different definitions of fairness. And along with it comes a lot of different metrics as well that we can use to measure fairness. And we actually try to check if these metrics are good and what they are actually measuring. And we try to propose corrections, new measures, and also guidelines on how to use these measures.
And so, as you said, there are different definitions of fairness. What's your definition of fairness in a recommender system? So what is really fairness, the fairness that you're looking for?
I don't really have a universal definition for it, but generally the aim is to ensure equitable outcome for the different stakeholders in recommender systems. So usually when we talk about recommender systems, there are at least two types of stakeholders: the users, of course, and also the providers who provides the item.
Sure.
Or like supply the items. Like this can be in the form of content creators or so like product sellers and so on.
Okay, and so what you're trying to balance is the fact that the user should get content that is relevant for the user and that is fair, so that is kind of good for everyone, so both for the user and for the content provider, right?
Yes, that's the general idea. So for users, it would be, as you said, getting good recommendations, and it should also be equal across different users. Like they should get equally good recommendations, right? Or also different groups of users, let's say. For the providers, it would be usually related to the exposure of the items that they provide. But of course, there are also other definitions that consider like also the relevance of the items or the quality of the items.
Yeah, of course, yeah. And you talk about metrics. What kind of metrics are usually taken into account when you try to measure fairness of the recommender system?
So that's actually the difficult thing, because there are really a lot of metrics and most of them are invented solely for recommender systems, but there are also some common ones like standard deviation.
Okay.
Or Gini index.
Okay. Can you give an idea what is the kind of standard deviation and the Gini index, just to, for the listeners so that they can better understand what we're talking about?
Sure. So standard deviation is the spread of the data, right? And then when we look into the standard deviation as a measure of fairness, we look into the spread of the, let's say, effectiveness scores across users, or we look into how evenly spread this distribution of exposure for content providers.
Okay. And what about the Gini index?
Gini index ranges between 0 and 1.
Okay.
Or supposedly ranges between 0 and 1. And then if the score is 0, that means that the score is distributed perfectly evenly across all the individuals. And if it is 1, all the exposure is only concentrated on a specific individual, which means that it would be highly unfair.
Okay, yeah. So basically both of the metrics are about, the exposure, if it is too focused on something, or if the exposure of an item is too much different from the one of the others, basically. So,
yes,
okay,
yes.
This is more or less the idea. And how can you balance fairness and relevance?
Yeah, we actually looked into this in our paper, which was published at the web conference last year. So we wanted to see from the data set because there are many data sets that we can use to build or train a recommender system and also evaluate them. And the idea is to build a set of solutions in the form of fairness and the maximum or the ideal fairness and relevance scores that can be achieved based on the dataset itself. So we are not dependent on the model performance, which usually is pretty low in terms of effectiveness. And we can then use these ideal solutions to measure how far our recommender model performance is from the ideal solution.
Okay. So, but in this case, you have two dimensions, right?
Yes.
Fairness and relevance. And did you find a way to kind of, let's say, get the best out of both of them? So how does it change with, because the way I see it is that probably there are likely some content that's very relevant, but that are with low fairness, let's say, and maybe there is also the other way around. So did you manage to find a way to kind of, accommodate both metrics?
It really depends on the data set. At least that's what we found during our research. And it also depends on how the data set is split between the training and the testing.
Okay.
There are many ways to split it. If you can use like random split, or you can first sort the data set based on timestamp, and then the first, let's say 60% goes into training, and then the last a few percent goes into testing. And then what we notice is that with a random split, it's actually possible based on the dataset to get a very high effectiveness score or relevance score, and also a very high fairness score at the same time.
Okay, cool.
So if you have like a two-dimensional plot where the x-axis is the relevance or the effectiveness score, and the y-axis is the fairness score, then and then assuming that both the fairness and effectiveness metrics range between 0 and 1, and then you sort of plot all the best possible fairness and effectiveness scores. So for a certain effectiveness score, you plot what is the best possible fairness score for that level of effectiveness. Then you get some sort of Pareto frontier, but this is based on the data set itself.
Okay. And yeah, can you kind of touch a bit about what is a Pareto frontier?
So Pareto frontier consists of solutions, or in this case, the fairness and effectiveness scores that are Pareto optimal. And a way to understand this Pareto optimal is that if you have an effectiveness score, a certain effectiveness score, and then you just take what is the best possible, or you try to find what is the best possible fairness score for that level of effectiveness score.
Okay, so yeah, so basically you fix a metric, you try to find the best that you can get from the other one. So try to maximize what is kind of the best of both, basically. So you do.
Yes, exactly.
Okay.
That's the idea.
Okay, and how did you reach this conclusion about having this kind of random split that will improve, that will make the best effectiveness approach?
I wouldn't say it is the best, because the practice of using random split for evaluation is not really a good practice, I would say.
Yeah.
Because it mixed up the order of the data and so on. But I would say that it produces the best effectiveness and fairness at the same time, because with random split, you have quite a diverse set of items in the test split. And because the items is diverse, the distribution of this item is kind of uniform in the first place. So there isn't really like some very popular items that are relevant to majority of the users. So that's why it's possible to achieve very high effectiveness and fairness at the same time.
Okay, cool. And are there what are the limitations or drawbacks of this approach?
One of the limitations is that it's very tailored to a specific type of fairness, which is the fairness for the items. And if we want to use this approach to another type of fairness, we need to create a new algorithm, basically.
Okay.
And another drawback is that the approach is quite computationally expensive because it takes quite a while to find the best solution in terms of effectiveness. I mean, technically, we can just take the test set, but to optimize it such that it also reaches the maximum fairness, the procedure takes a bit of time. And also to enumerate all the other ideal solutions, that also take a lot of time, unfortunately. But we also try to come up with a more efficient version of it.
Yeah.
So that instead of enumerating all of the possible solutions, we just pick, let's say, how many solutions that we want to have, maybe 10 or 20 or something, right? So instead of having a very dense frontier that represent all the solutions, we only have a subset of it, but the points can be spread quite evenly between.
Maybe a kind of a weird question, but do you see, any practical application of this kind of research that you did, so about fairness and relevance? Do you think it can be applied in industry for recommender system, proposing me, I don't know, TV shows or music or whatever?
I think it depends on the goal of the company, right?
Yep.
I mean, do they really want to maximize only engagement for users, or do they also care about the content providers? But I think this can be used during the offline evaluation phase because this was designed for offline evaluation. So let's say if you want to do A/B testing or online evaluation, then this is not the best approach to do it because it's also expensive.
And what have been the next step?
So I think in the first year of my research, or in the initial stages of it, we focus more on trying to understand what the measures are measuring, right? And then we try to propose small corrections that do not change how the metrics work, but they're, let's say, a little bit more accurate in measuring fairness and not misleading. And then we move to proposing new metrics that addresses the limitations in the current measures. And then we move on to providing guidelines on how to use the measures. And now we are more concerned about how to make the metrics available for the broader audience. So we are planning to create a library for fairness measures in recommender systems so that people can actually use the measures easily and not have to look into the individual paper and see the metric equations and implement the metrics themselves. And we are also working on testing the statistical robustness of the measures so that we know what are the limitations of these measures in terms of their statistical robustness.
Well, Theresia, thank you very much. It was a very interesting chat, and it was a pleasure to have you here.
It's my pleasure as well.
So thank you very much for listening. And if you like the content, remember to leave a nice review on whatever platform you're getting the podcast. Yeah, you can find a link to relevant papers in the episode description. And see you at the next episode of TARGD.